Welcome to Floating PV and the Floating PV Design and Construction by ATA Insights. So in this webinar, our two expert speakers, Andres Franco from AC Floating and Oliver Philippon from Seletar, will give you an idea of what's happening in the world of floating PV design and construction. And today will be your chance to ask questions. You can do so through the Q&A box. And also we have a tradition here in ATA Insights in which we, through the chat box, we get our viewers to share where they're joining from. So we are here with my colleague Araceli from Madrid in Spain. So don't be shy and write on the chat box, say where you are joining from, and welcome all of you. And I'll get the two speakers to introduce themselves briefly as well. So Olivier, could you introduce yourself briefly, please, and tell us where you're joining us from?
Yes, so good afternoon. My name is Olivier Philippon. I am the Engineering and Project Director for Seletar. And I'm in charge of the design and sales support team globally, and I'm joining from Thailand today.
Thank you very much, Olivier. So if anyone else is joining from Thailand, raise your hand, put it down on the chat box. And Andres, could you please introduce yourself briefly?
Yes, thank you, Carlos. My name is Andres Franco. I'm the CEO of Hinari, and I'm joining today from Madrid, Spain.
Thank you very much, Andres. And Andres, you'll be first to present, so please get your presentation up and get ready to deliver your presentation. I can see it well if you could. There we go. Perfect. So over to you, Andres.
Okay, thank you, Carlos, and welcome everyone to this webinar. I hope we get you some pearls of wisdom today. We were just chatting before with Olivier that I know there might be many questions, and sometimes some of the answers will be, it depends, but that is the thing. Designing and construction of a floating solar plant is not a recipe. We will try to give you some insights. I will start more with the generic of floating solar design and construction. So just to start very quickly, what Hinari and our system AC Floating, what we are doing. First, our company Hinari, we have our mission to help preserve the world by using the existing water bodies that exist in our planet to generate renewable solar energy in a more efficient way, while at the same time we protect scarce water and precious land. This is a company that it's a Spanish company. It has been around since 2008, and it all started when engineers in Spain were trying to solve the problem of water evaporation, and then they realized that it was also needed to have energy for the pumping systems in agriculture. And we are right now in this 11th year of operation. We have a floating solar technology which enables the covering of partial or entire water surface. And as you may be aware, many of our people that are joining us, it can be used in many different type of water environments, from the really, let's say, complex ones like hydropower plants, or let's say to more simple ones like irrigation reservoirs. And of course, the design changes from site to site, and it's important to bear that in mind. If we think about a generic floating solar plant and taking series schematics, we believe that there are three things that need to be thought in a different way. The electric part, talking about the modules, the inverter, then the structure, and finally the anchoring and mooring system. And you need to make decisions on each of those three separate elements, and also while in construction, to do it also in a combined way that optimizes the whole project. What do we believe are the key challenges that need to be solved in a floating solar system? And these challenges are important to keep them in mind while doing the design and the construction. The first is around adaptability, that this is not like ground-mounted systems that are sitting still, not moving. You have water, you have the wind moving, putting stress on the structure. Water levels can go up and down significantly. We're looking right now at a project in Latin America where the water level changes 43 meters. So that's very significant. Also, the logistics is a challenge, especially from a cost perspective, to not pay for air being transported. Installation, very key. You want to have your project up and running quickly. Installation needs to be safe. And talking about maintenance, the safety on maintenance, what we're seeing in many companies, is becoming more and more critical. It's a key aspect, and the large EPC companies, large developers, they find that this is a key thing of the whole project. Also, the floating solar plants need to be nature friendly. They must integrate and preserve nature where wildlife exists, but at the same time, they need to be resistant. They should be able to stand Mother Nature and stand the combination of the sun, the wind, the waves, the snow, like many, many elements that will be impacting the floating solar plant for over 25 years. So with those challenges in mind, what happens, and these are real life examples, what happens when maybe not enough time was devoted to the design and construction? Unfortunately, some of you might have seen these pictures. These are things that happen in certain places when strong winds, there might be problem of design, or there might be extra cost in the logistics and the storage of the floats. There might be problems while running because of the cable that go into the water. There might be safety issues because of the cables and not safe enough, or there might be even problem with insulation or problems with the buoyancy. That's also frequent. Yeah, and unfortunately, this is happening, and there have been institutes like CIRS who have documented this extensively. And of course, you need to keep this in mind when you're designing. And when you're designing, you can design, let's say, a car to have a fast car, an expensive car, or a cheap car. And what do we believe that is the main element that need to be kept in mind when you're designing? We believe the three main needs in the industry are around durability of the floating solar plant, how the operation and maintenance will be handled in a secure way, and of course, to make the project economically viable, and hopefully as close as possible to ground-mounted system when there is an option. And if you want to design for that, we believe you need to take into account 4 key factors. You need to have a design that is high quality, that is safe, that is adaptable to the water body, and of course, that is cost efficient. And unfortunately, there's no one-size-fits-all solution. To give you an idea, we are showing here, let's say, 3 different types of projects depending on certain characteristics and complexity. And you can see that, of course, the solution that we design for a project that is of type A will be very different to the one that we are designing if it's a type 3 project. Cost will be different, safety issues will be different, and each project requires a customized design that adapts to the specifics of the reservoir. And what are those specific? What are the elements that we advise to keep in mind when you are designing? So I would say that the most important one are the list that is here. So it's the first one is the years of expected operation. If you're designing for a 15-year installation or a 25-year installation, how big is the water body? What's the maximum depth? And what will be the water level changes? The wind, the design wind, and also the peak winds. Also the waves, it's a key aspect of the design. In certain areas, snow could be an issue. And also talking about the water body, the type of bottom and slope surface could be relevant to the design. Water salinity, the currents, if you are designing a place that might get currents, and of course, the climate, the temperature around that. So when you're designing and when you're looking at your water body, it's important to try to get all this information, because that will have an impact in the design and will have certain implications. For example, talking about the expected length of operation, you might need to change the quality of the floating structure that you are using, the thickness or the type of additives that you're using, depending on the size of the water body, what's the percentage that you will be covering to make sure that you're minimizing the potential environmental impact. What's gonna be the type of anchoring that you can use when you have options. The flexibility of the structure is very relevant, especially when you have high waves, because it's shown that when there's no flexibility in the system, the waves will break the components, and you need components that hopefully will adapt to the movement of the waves. Buoyancy, it's also a key implication. Buoyancy, looking from different aspects, from the worker's perspective, from a safety perspective, the inverters, the cables, depending on the water salinity, electrical equipment, issues around insulation or corrosion might be an issue. Logistics we mentioned, and the safety of the workers in the installations. And when you are looking at that and you're thinking, okay, those parameters have implications, you also need to keep always in balance that if you want to optimize and reduce risk, that might mean that you need to increase certain cost. So it's a very complex, let's say, equation, but it's something that we like a lot. I'm gonna show you now some of the rules of thumb of a good design that should be, in our experience, should be taken into account. And again, this is not a recipe, you need to adapt it, but if we look at the structure and the electrical part, the modules, the inverters, and the cables, and the anchor and mooring, some of our rules of thumb would be talking about a structure, that design with a structure that will be able to withstand combined mechanical stress and fatigue of the materials due to the constant water movement, to the UV radiance, to the wind, to the weight load, and to many other factors during sometimes usually 25 or more years. Also, when you're design, and from a structure point of view, bear in mind that when you decide what structure you're gonna be using, that could be the direct cost of the structure, the floats and the connections. At the same time, you are also deciding what's gonna be your associated transportation, installation, and maintenance cost. So it's not just about the direct cost of the structure, but also how much does it cost to get it there, to install it and maintain it. Also, talking about a structure, we think it's very important to define and design what are the minimum thickness, what are the strength that the anchoring points should be able to resist, what could be the maximum additives from looking at UV additives and anti-corrosion that should be still considered safe by European standards or by the standards of the local place where you're designing the floating solar plant. And finally, structure, and again, this is more and more important nowadays, the health and safety factors. How can you design to minimize the holes in the structure and there are no risks that somebody can fall, to increase the buoyancy, to even if you can, to attach safety elements to the structure. It could be railings or life vest. This is becoming more and more important. If you look at the modules, inverters and cables, go for high quality modules. We believe that there should be no quality compromise there. 72 cells panels are working well from a cost perspective, because at the end you are paying less for the structure. Frame, glass to glass, well, maybe you need to look at the weight. It's important, it's a good option, but might put more weight on your structure, and maybe you need to put a better structure with higher buoyancy. And if you're looking at the inverters, there's always the question, what should I use, a string inverter or central inverters? So you need to think about the availability of the plant, you need to look at the total cost of the cables, what's gonna be the distance to the shore, have a minimum qualification of IP67. And when you look at the cabling system, we believe that you should design so that the cables should always be air ventilated, they should be structured, ordered, and that the supporting structure should be designed so that there will be no submerged cables at any point, and only with the exception maybe of the evacuation cables, that in that case you should use cables with maritime specifications. And finally, the anchoring and the mooring, try to use as much as possible onshore versus bottom, if possible, because it reduces significantly the cost of installation and operation and maintenance. Bear in mind that the higher the panel tilting, the higher the wind drag that will be sustained, and therefore the higher the cost of the structure. When you're thinking about the studies, it's not easy to find this study, the hydrodynamic studies, but it's very relevant, especially because you need to look at the currents that are on the site. And sometimes the currents could be really strong and you need to reinforce the anchoring and the mooring. And finally, if you have project that has significant changes of water level, maybe more than 20, 30 meters, we advise going for some elastic anchoring systems like C-Flex that you might know about that. So that's what our recommendation on design. And if we go into construction, we believe what is more important is to try to have a construction that is simple, that is cost effective. So here we're gonna show you one video of the installation. It's a 1-minute video of the installation that shows you some of the good parameters that we believe are important. So one is that installation should be done as much as possible on the ground from a safety perspective, that you give ergonomics, that you use simple tools, what we call IKEA-like tools to attach the components, that it should be safe for the workers from an ergonomic point of view and from weights, that the components can be put together in an easy way. So this will speed up the process. And then when you're doing the launching of the system, that it has to be in a safe way. So in this case, you're seeing it's a system that has a big, as you can see, significant variation of water level. And even in some parts, there's almost no water at all. So all of these mean that you need to do a lot of planning. You need to understand very well your site before getting there. But well, it can be done. Yeah? And if we look at what are the key and also the idea that we want to leave you with on construction, first recommendation, plan, and if you have some additional time, plan. Especially things that we have seen in our experience, issues with not enough stock of materials or not optimizing the movement of the materials. Also, bear in mind that not all the materials take the same amount of stockage space. It's important to apply elements of lean production and movement of materials so the people will be focused on building and not moving. And another thing that it's a small detail, but sometimes it can increase the efficiency, is to build a good launching platform. And you can see here, this is a real case example of a site where almost this was all the space available. So this required a lot of planning to make sure that the construction could be done because there was not a lot of space available. And that's something we tend to find in many of our sites. So that's it. Thank you very much. And we'll answer the questions in a while. Now over to you, Olivier, to go into the specifics.
Thank you very much, Andres, for your presentation. So yes, you need to, if you can stop sharing your presentation, please, Andres, so Olivier can share his. Thank you very much. And right, and I've seen that questions have started coming up on the Q&A box. So whilst Olivier gets his presentation ready, I'd just like to remind you to pose questions. And, you know, as I've said it before, but I'll say it again, you will get a recording of this webinar and you'll get the presentations a few days after the webinar as well. So straight on in your inbox. So, you know, not without any further ado, please, Olivier, over to you.
Thank you very much, Carlos. Thank you, Andres, for this nice presentation. So during my presentation, we will go through the different steps of construction. So it's really focused on construction of floating PV plants, and especially focusing on important aspects that are specific to the floating. So just to briefly introduce Seletar, which is the well-known pioneer and world leader of floating solar market. So the company was founded in 2006, started developing the floating technology in 2011, and after 2 years we installed the first 1 megawatt project in Japan. Today, we have over 150 plants connected around the world using our Hydrelio technology. This is our case study for today. So it's a 540 kilowatt peak plant connected in 2018 in Hyogo Prefecture in Japan. This is of course not the biggest installed plant with Hydrelio, but this one is one of the 15 Seletar has developed, designed, constructed, and is currently maintaining and operating in Japan. The reason for me to choose one of these is because we get to see our product during the entire lifetime of the project and the operation. And it also gives the full picture of what is a floating PV system. We are, by the way, using some of these floating PVs to test new technologies and monitor our plants. For example, we have installed load cells on mooring lines on one of our plants to correlate the wind tunnel calculations and CFD to a real case. And we will soon do the same for the wave behavior to correlate with the simulations. So this plant, as I said, is 540 kilowatt peak. It's using Japan Solar 60 cells panels and Huawei string inverters 40 KTL on water. As you can see, the inverters are on water. In a case of a small reservoir with no waves, our conclusion is that LCOE-wise, string inverters on water is the most economical solution. We don't use 60 cells panels anymore on our plants. We use 70 cells high capacity PID-free modules, and we stick to frame panels. Our experience is that frameless panels are not strong enough for this kind of application. Again, everything that I'm saying is applicable to Seletar own developed plants, and this is our choices and may not be the choices of different developers. So going now to the main subject, construction activities, the different steps of a floating solar plant construction. I have purposely shown only activities which are related to construction, not mentioning procurement, for example. The first step is the pre-engineering. Pre-engineering is very important. I'm coming to that right after. The anchoring is the second phase, and it shall be the second phase. It shall be done prior to the assembly phase. For big projects, you could start assembly while you are still finishing the anchoring on other islands, but at least you need to have finished the anchoring of the current island while you are starting the assembly. The next phase is the construction and commissioning, and that requires, as Andres said, planning, planning, and planning. It needs to be well planned in advance to avoid any problems on site. And finally, we will finish with the O&M, which is not so much different from traditional PV, but which have small specificities that we will mention. Pre-engineering. We recommend to start with a site visit. So the purpose of the site visit is to identify potential constraints of the site for assembly location, for instance, or for areas that should be avoided. Second step is the bathymetry of the reservoir. So most reservoirs are not flat. Some of them are, but some of them are not. And we need to have accurate depth measurements of the reservoir for each anchor point. It's very important. So we can do an anchoring design which is relevant and which is based on real data. Also, during the pre-engineering, it is recommended to do soil tests to determine which anchors shall be selected and to size the anchoring. Finally, the output of this first phase is the anchoring design of the plants. We can then move on to the anchoring phase. positioning accurately the anchor points and measure their exact position is key, as I mentioned. So it's not only about having the data, it's about having the exact position of each anchoring points to be able to do an as-built design of the anchoring system. The methodology for anchoring is depending on the depths and soil conditions. Here in Japan, for example, for this site, we are using the barge that you can see on the bottom right part. And this barge is used to drive driven anchors into the reservoir bed. And the depth, for example, of this reservoir is less than 5 meters. So it's quite an easy anchoring for these specific sites. After you've finished anchoring, you have to moor the cables to the, you have to connect the cables to the anchors. But first, before you connect and before you attach them, you have to verify the mooring lines as built lengths. This is also very important. You cannot base your design on a length of a mooring line which is plus or minus a certain number of centimeters. This simply doesn't work. Then you have to test your anchor points to make sure that the capacity of the anchor meets your design requirements. And finally, you have to compile all the as-built data that you had, the length of the mooring line, the position of the anchors, the loading of the anchor, and everything. And you put that into an as-built drawing and an as-built calculation before you move on to the next step. Next step being construction and commissioning. The assembly sequence must be planned properly, and construction drawings shall be there to reflect the cable arrangements, but also the sequencing. When are you going to install which part of the island? You are not going to assemble the full island in one day. You have to know which part you are going to assemble first, and up to where the cabling will be done on the shore. Then the platform will be loaded out and towed to the site and immediately connected to the anchoring points. If if the island is not finalized, you have to connect the sides which are not finalized to some temporary anchors which can sustain the environment loads. That's also very important. We've seen some incidents on some sites where the temporary anchoring was not properly done, and I can tell you it can be a big issue. Next step when the island is positioned is to finalize the cabling, is to terminate the cable. So you can see the state where you are at this stage on the bottom left side. So the strings are pulled. Now you need to connect to the string inverters or to the junction boxes. And very important as well, you need to protect your cables from UV and from the water. This is important. All the cables are not protected by the structure itself, as it is most often the times on the ground system, and it's not naturally protected from the water. So you need to make sure that all the cables are protected from the water, either by being far enough from the water or by being protected inside some cables. Protection, as you can see on the bottom right side. The commissioning, I would say the only difference with a traditional PV system is the risk assessment that shall be adapted to water conditions. But apart from that, I don't really see any difference with the commissioning of a traditional PV plant. Now let's finalize this presentation with the operation and maintenance. So according to the O&M manual of the equipment supplier, you have to do some checks regularly on the mooring system on the support structure itself. I mean, the same as what you have on traditional PV, and it's slightly adapted to the fact that the platform is moving. I mean, it's not a stable environment, it's water. You can have, as Andres mentioned, you can have very small waves, you can have mid waves, and you can have significant waves on your reservoir. So you need to make sure that nothing is moving and the structure is properly maintained, and that there is no significant changes from the initial stage. Finally, you need to do the cleaning of the platform. You need to do some checks on the panels, some checks on the inverters, but that's very, very similar from the traditional PV. So I will not mention that. You can see someone cleaning the panels on this picture. You can use the water of the reservoir if the water of the reservoir is clean. If it's not clean, then you need to bring water. What we see on our plants in Japan is that we don't wash them as often as ground-mounted PV O&M people do, for the simple reason that you have less dust, and the dust is often, if the reservoir is big enough, the dust will be catched by the water before it goes onto the panels. The only slight issue that you could have are the birds. And here it's about site selection. You have to make sure that you select the sites on which you have not, you could not have some significant bird problems. We have experienced only bird problems in the UK and in Belgium, but not in Japan, not in the rest of the world. That's about it for me. If you have any questions, please do not hesitate to ask.
Thank you very much, Olivier, for your presentation. Very, very interesting. If you could stop sharing your slides as well, so they can see us during, the viewers can see us during our discussion. Thank you very much. Right, so we have a lot of questions today, so let's start so we can get most of them answered. So the first question is by Arthur, and he's asking whether there was a question here about the what technology you use to measure the level of water in reservoirs, you know, and Arthur says some reservoirs are dry during low tides or dry season. How do you manage that?
Okay, Arthur, in our experience, it's important that you design so that when that happens, everything will work perfectly. For example, with our system in the structure, it works even with no water. And you saw in the last video that we were showing on the installation that there was parts where there was no water, and that happens in many regions. So it's important to have a structure that when it's sitting on top of the bottom surface, it will not present a problem. But however, it can also happen that in certain reservoirs, if the type of bottom surface, it's pointy or it's not stable, it's not kind of flat, that this might not be a good option to install floating solar plants in those reservoirs. The same situation as it happens in ground-mounted systems, that you cannot build a ground-mounted system in any place. That can also happen in floating solar. Not all the water reservoirs are good fits for a floating solar technology.
Thank you very much, Andres. Olivier, I don't know if you want to add to anything to that answer.
Just would like to add something about the water level variation. So regarding the water level variation, we have a pilot installed on an EDP site in Portugal, and the water level variation is 30 meter variation. I mean 30 meter from the highest water level to the lowest. So the anchoring system has been designed according to that, and to make sure that the floating solar plant would be under tension and would be resisting to the wind and to the waves, whether the water level is low or whether the water level is high.
Thank you very much, Olivier. And then our next question is by Thomas. It says, is it realistic to think there will be floating plants in open coastal waters? So over to you. What are your thoughts on this?
Well, I would say that we believe that will happen. In fact, we are already looking at a pilot project for a large fish farming company in Europe to put the system in coastal areas. The biggest challenges that we are looking at right now are related with the potential corrosion of the electrical equipment, talking about the solar panels and the inverters, due to the salty water. And the second, it's around the cleaning process, because it might happen if with the seawater, that when the seawater dries, it leaves the salt, and the salt sits on top of the solar panels, and that might create some issues in the operation. So from a structure point of view, we believe that there are already examples in the maritime environment. You have structures that are in the middle of the ocean, for example, for wind farms or for petroleum equipment that work, and they can manage big waves, strong winds. But the challenge is more around with the electrical equipment.
Thank you very much, Andres. Olivier, have you thought of floating PV farms and sitting on coastal waters?
I mean, we have in our pipeline some projects which are on the coast. Most of the time, it's in areas which are protected, so it's not open sea. It's lagoons, it's sheltered seawater. So as Andres mentioned, there is this corrosion issue, and I would add one point, which is the fatigue resistance of your structure has to match the site conditions. If you get waves every day during 25 years, you have to make sure that you can demonstrate that your structure will be able to withstand the fatigue damage of this site.
Okay, thank you very much. And one question that I saw that was a general question, but I'm sure that many people, many are thinking about these questions. So what are the main differences between a ground-mounted PV system and a floating PV system? And the main similarities, I suppose.
Well, I would say main differences, probably the biggest one is that the place where you are sitting, the power plant, does not stay still. It's constantly moving. As Oliver said, even if there are no waves, you will have the fatigue of the material by the constant movement and the impact of the wind that creates small waves, of people moving around. So I think that's the largest difference compare. And of course, in order to manage how to handle and to fix the structure, the anchoring and the mooring works in a much different way compared to a ground-mounted system. But then there are other things that are similar. It was mentioned the operation and the maintenance, and you need to keep some of the standards the same. So we believe that security there should be no compromise around security, and especially many companies are even more concerned because you're doing this on top of the water and you have electrical current. The earthing system needs to be designed in a specific way so that there are no issues around that. And also it's important that the workers, when they're doing all the cleaning, all the potential maintenance, changing the solar panels, that they have enough certainty that there will be no problems. This is one of the key issues that was identified by Series in the study that they did, that they're doing on floating solar systems. The security is one of the things that is still, there seems to be work to be done to assure 100% security.
Thank you, Andres. Oliver, anything to add, or should we move on to the next question?
I guess we can move to the next question.
Okay, so it's a question by, next one I'll choose is a question by Chico, which reads that the biggest advantage claimed of floating PV is lower thermal losses. But there isn't much information there about this. What is the this effect, that the cooling effect that you get for floating PV plants, and is there any way to measure it? Is there simulation software out there that can measure it?
I guess the best way to measure it is to compare actual plants producing on floating PV or on the ground or on rooftop. And I invite you to read the series report on this matter. It says that there is an increase of production. I think between 5 to 15%, I would say, depending on the type of floating system that you are using. But obviously, the series is comparing with the rooftop because Singapore doesn't have any ground-mounted system yet. So, as Andres said at the beginning of the presentation, I would say it depends. It depends whether it's between rooftop and floating. It depends whether it's between a well-ventilated ground-mounted site and a floating system. But generally speaking, there are some facts that you cannot deny, which is that the thermal loss is less, and the conductivity of the air when there is moisture is higher.
Okay, thank you very much, Olivier. If you could actually share the name of that study in the chat box, that would be appreciated, because I'm sure that many would like to consult the study. Right, there are many other questions. Let me choose some of them. Right, so I think you did talk about the pre-studies required to for floating PV. So that one is probably not the best one. Right, how about, there's an interesting question here that has to do with dealing with ice. So have you had an experience building plants in reservoirs that get frozen over during the winter, and how have you managed it?
Well, we haven't built a plant on top of a lake that gets completely frozen. We have built on places that get significant amounts of snow. And I agree that that's a challenge that is still, the jury is still out, because from our studies and the tests that we have done, when you have the ice formation, it puts pressure on the floating structure. So when the ice expands, and it could put significant forces of strength on the structure. Also, what happens with the anchoring and the mooring, because at the end, if the ice forms around the cables, the ropes, that's an extra weight that at some point the anchoring and mooring system should be able to manage. Or maybe the behavior of the anchoring and the mooring will not be the same, because you have something that is solid and is not flexible, and maybe the buoys are not behaving the way they were supposed. So right now we have looked at some studies and also some projects on ice, but I would say that this is something that not completely understood on how to work on those sites.
On our side, I mean, we've had some plants in Sweden and in the US, in Colorado, for example, and also in Korea, where we get, I mean, where the water reservoir gets completely frozen. I would say when the reservoir is relatively small, it's not really an issue. I mean, we've had like 2 or 3 winters where we had no issues. But our Korean partner had some issue on a very big lake where you have a river coming, and when the river is coming, so there is water flow, so the ice formation is going to be later than the ice formation of the rest. So you could get significant difference between 2 locations. So you just have to make sure that your floating solar plant is not located close to that gap, because otherwise it could be, I mean, it could be one part could go with the river flowing, and the other part could stay. So what our Korean partner did is that he moved the plants to a safer location where we have no issue so far.
Thank you very much, Olivier. We have a number of questions that have to do with operations and maintenance, and one question has to do with financing. Let's go for the I&M questions first. So asking how are whether there is a track record of the most common problems and the parts that need to get replaced the most often per megawatt installed, let's say. Or common failures, let's put it that way.
So I would say common failures is could be from the, as we mentioned, could be coming from the waves. When the waves are significant, you need to have proper system to attach your cables. If your cables are, if there is no slack in your cables, then the cables could be significantly damaged when the waves is going across the plant. That's the first item. It's cabling. And the second item as well is the connection between the different parts of your systems. They have to be properly sized to make sure that they will resist to the waves. So we've seen some plants where you have to change the connection points at some location because it gets waves.
And in our experience, we have our oldest plant was built 10 years ago here in Spain. And we have seen that there are some things that are critical in the system. As Oliver mentioned, one thing is the connection between the elements. So that's why I was mentioned that some parameters like the thickness of the floating structure is key, because you will have a lot of fatigue of the materials. And also UV exposure reduces some of the properties of flexibility of the HDPE polymer that is used in many floating solar structures. Also, it's important that we have seen certain installation issues with puncturing, depending on the type of bottom surface that you might get, and also issues, as Oliver mentioned, on the anchoring points that are connecting the anchors to the structure. And if the structure, the part that is connected to the anchor, when strong winds come, when waves come, that will put a lot of mechanical stress and might break it. So you need to design in a way that it will be able to withstand those forces or increase your operation and maintenance cost.
Okay, thank you very much. Then we have a question regarding earthing and how does the lightning resistor system work? So over to you.
So the first question is about earthing, right? If I understood correctly.
That's correct, yes.
Okay, so regarding the earthing, we do the same as what is done on traditional PV, which is that we have an earthing cable going from panel to panel, and then this earthing cable goes to a junction box if you have on the platform, and then there is a main earthing cable going from the platform up to the shore on the proper earthing. I've seen some studies on internet saying that we could earth the plants to the water reservoir or to the bottom of reservoir, but we've never done that yet.
Okay. In our experience, it's pretty much similar to what Olivier was saying. We prefer going for earthing on the shore. So far, all the plants that we have built have been that way, and we are using the regulation and the guidelines that are used in under the European guidelines for solar plants. So it's something that needs to be done. That, of course, because you have water and energy together, it raises a lot of questions. But as long as you plan it well, it doesn't have any issues in the structure, and it will work fine.
Okay, thank you very much. And you know, on the we have one question on financing here, which are you know, whether you are facing any particular challenges to obtain financing on your projects, given the innovative nature of the of floating PV.
I would say no. It requires a bit more due diligence from the banks than a traditional ground-mounted PV. And this due diligence has to be done by a recognized third party which has knowledge in solar, but also in marine systems. So that's the challenge I see. Apart from that, I mean, we get financing, we get even non-recourse financing in some countries for floating PV. So I would say no.
Okay.
I would say in our experience, I would say that depends on the type of market and the type of financial institution. Of course, this is new, and I guess markets like Japan are much more mature around that. But we're seeing that in the Americas, well, not all the commercial banks, when they're looking at it from a project finance perspective, that they are open. They have this issue around technological risk. And sometimes the appetite for risk on those projects for those banks is not as big. So I think this is something that will be solved. We are working with certification agencies to try to define what are the key criteria that should be used, let's say, in a more standardized way. Because if we are able to define standards, it will be easier for the whole industry and for the traditional commercial banks to provide the financing in the project, no matter where the projects are located.
Thank you very much. Then I think it'll be one of the last questions we answer. There is a question on how you deal with corrosion. They talk about particularly about salt water, but do you have experience dealing with corrosion in your floating PV plants, or any recommendations?
I mean, when it's not in salty environment and it's in freshwater reservoir, I would say there is. I mean, the components that we are using for the floating system are not sensitive to corrosion. I mean, HDPE plus anti-UV and aluminium. So I don't see any corrosion issue. And for the rest of the electrical materials, anyway, they have to be resistant to significant rains and everything. So for me, no corrosion issue when it's about fresh water.
Okay.
And what we're seeing with corrosion, again, if it's a freshwater reservoir, as long as you are working with, let's say, a minimum protection degree of IP67, if your cables are well designed and are on top of the structure, or if you are using cable for the evacuation that are maritime grade type, we're not seeing any significant problems. And on the but we believe that if you are going into salty water, that more information needs to be extracted, because corrosion might be an issue, especially on the electrical equipment.
Right. Thank you very much. And well, and to close the webinar, the last question has to do with markets. So Sebastian Cochet asks, do you see some countries where floating PV is more mature or accepted than in others, and which are these markets? So on which markets do you see more instances of floating PV plants?
On our side, what we can see is that it all started in, I mean, the first utility scale project was done in Japan. So it all started from Japan, and then it contaminated Asia, China, Korea, Taiwan, and then it's moving now to the west. We see some significant plants coming to Europe, to the US as well, Latin America. So far, what I've seen is only small plants, but it's coming. So it's coming from the east to the west, I would say. That's what we notice on our side.
And from our side, apart from the, I agree with Oliver, it's mainly Asia. And one country that is picking up momentum, and they are launching more and more projects, is India. It's interesting to see that there are some countries that are betting big. India is planning, the official announcement was to have a 10,000 megawatts of capacity of floating solar installed by 2023. I think it's the deadline. Or Singapore as well, they want to have almost a third of the electricity coming from floating solar. So a lot of movement in Asia, but it's also coming into the other regions of the world. So I think this is gonna be a fascinating industry. And we believe that floating solar will be a complement, will be another technology that whenever there's a concern for water evaporation, for land conservation, floating solar is a great option. And this is not always a question of competition between ground-mounted versus floating solar, but it's about complementing the mix and taking the best solution in each instance.
Thank you very much, Andres, and thank you very much, Olivier. I think, it's 2 minutes to the end of the webinar, so now it's time to wrap it up. So I'd like to thank both of you for being here, and also to our audience, of which there were more than 100 people today from 3 different continents. So pretty good going for being with us. And I don't know if you would like to say a few parting words to our audience.
No, I mean, thank you very much to all attending this this webinar. We will be more than happy to answer further questions. So there is an email address in our presentation. If you want to ask specific questions, feel free to send. And that's about it. Have a good end of afternoon in Europe. For me, it's time to go to bed in Thailand.
Yes, I was going to say thank you. Special thanks to you for being online at from 9 till 10 o'clock at night. So kudos to that. And Andres, any parting words?
No, again, thank you to everyone listening to us, and we're welcome to join us in this crusade to show the world all the benefits of floating solar. I know there are challenges. This is a very new thing, but that's what happens when you want to be innovative. You need to convince the skeptics, you need to try, you need to adjust, you need to learn. But I think on the ground-mounted systems, early on, when there were the first ones, it took a while to become mainstream. But we see that happening, and would be more than happy to go with you on this journey and build a lot of floating solar systems.
Thank you very much, Andres. Thank you very much, Oliver. Thank you, all of you. And remember, at atainsights.com, we'll have a lot of other webinars as well, which might be interesting to you. So check out our page. Thank you very much, and have a good day. Bye-bye.
Bye.